Assalamualaikum and hello everyone. Welcome to the video where I'm going to explain the solutions for the examples on page 10. Okay, so for the chapter 4 itself, it's actually it is not included in your exam, only for your assignment. So I'm not going to be focusing much on this chapter. But then for the 4.3, the isomerism, I believe the tricky part a bit, only a bit, is actually for the structure isomer. Yang tricky part here is actually where contohnya dia bagi the compound, then you have to draw all the possible structure isomer. Tapi most of the time for the tutorial, sometimes for the assignment, usually the question is quite straightforward lah. So for this one, let's do it together because I believe contohnya kalau kamu dapat buat pun, you can't get all the maximum number of isomer. So let's discuss it together. Okay, so first, what I'm gonna do for any type of for the structure isomer, you're gonna write down how many carbon, hydrogen, and oxygen present lah. Okay, so here we have C4H10O1. So it follows the molecular formula for CnH2n plus 2 and oxygen. So when we look at the functional group isomer, it is actually between alcohol and ether. So for the possible isomer, you're going to do for both alcohol and ether. So what I'm going to do first is actually for the alcohol. Okay, so again, when we know that it's alcohol, we're going to do the chain isomerism first. So for the chain isomer, so we know that we're going to write down the longest carbon chain is equal to 4 and the longest carbon chain is equal to 3. Okay, so when the longest carbon chain equal to 4, so we're going to do a straight line again. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so but then for this case, when carbon chain is equal to 4, actually we can change the position of our alcohol. So here is actually on carbon number 1, here is actually on carbon number 2. So for this one, it's actually a positional isomer. Okay, that is for the carbon equal to 4. So when the longest carbon chain is equal to 3, so the same thing, 1, 2, 3. Sebab kat sini kan, the longest carbon chain, anyway you count it, you will get the longest is 3. So ni pun sama je. Okay, but the difference between this is actually here, the OH is on carbon number 1. Here is actually the OH is on carbon number 2. Okay, so for the alcohol, I hope you get it yourself. Yang ini quite straightforward sikit. But then, the possible isomer ada 7. So how do we get another 3? So actually dekat sini we have ether. Ether ni is actually when your compound is C, oxygen C. Maknanya apa ni, your oxygen tu bodyguard dia is carbon, COC. Okay. For here, what I'm gonna do is actually, we know the carbon is 4. 1, 2, 3, 4. So first is actually when I write down the oxygen between carbon 1 and 2. This one, yang bawah ni, is actually when the oxygen is between carbon number 2 and 3. Okay, so we get another 2. Okay, so how do we get here? Yang tengah-tengah ni macam mana? Okay, here is the same thing. It's actually your oxygen is between carbon 1 and 2 dekat sini. It's just that for this case, 2, 3, 4 ni macam straight line kan? 2, 3, 4. It's a straight chain lah. Tapi dekat sini the 2, 3, yang ke 4 ni kita buat branch. So that is the possibility of isomer for example A. Okay, next is example D. Okay, example D follows the formula of CnH2nO2. Okay, which is the functional isomer. Kalau oxygen 2, it's actually only carboxylic acid and ester. Okay, carboxylic acid is where C double bond OOH. And this COOH must be at the end of our molecule. Okay, so here, kalau dekat sini, memang tidak ada for the carboxylic acid, there's no positional. We cannot change it. Sebab COOH must be at the end. Okay, but then kat sini, kenapa ada 2 possible isomer? Because this one is actually when carbon is equal to the longest carbon chain is equal to 4. This one is actually when the longest carbon chain is equal to 3. Okay, but then when we count the carbon, still 1, 2, 3, 4. This one pun 1, 2, 3, 4. Okay, so that is for carboxylic acid. Okay, how about ester? For ester, dia macam ether, kita punya ether juga, kita ada COC. Okay, tapi dia punya extra dia, ester ni ada double bond O dekat sini. Okay, so sini pun mesti carbon. So for this case, the oxygen dengan O ni, it is not at the end. Actually here, we can change for the position. We can change the position of our functional group. Sebab COOH must be at the end. Kalau yang ester punya, dia sebenarnya tak boleh at the end lah. Dia sebenarnya kat tengah-tengah. Okay, so here, when we count back here, the 1, 2, 3, 4. 1, 2, 3, 4. So for the first one ni, it's actually our double bond OO ni between carbon number 2 and 3. The second one is between carbon number 3 and 4. So that is actually for example D. Yang ni macam lain sikit kan? Okay. And the last one. Last one ni yang ada 10 possible isomer. Banyaknya. Okay, how do we get there? Okay, so first, it follows the CnH2n. So it means that we have alkene and cycloalkene. First, what we're going to do is for the alkene. Alkene is actually our carbon-carbon double bond. Okay, so first what I'm going to do is actually do the chain isomer, where the longest carbon chain is 5. Okay, so when it's 5, 1, 2, 1, 2, 3, 4, 5. Here pun 1, 2, 3, 4, 5. So what is the difference between these two? Here the double bond is between carbon 1 and 2. Here is actually between carbon 2 and 3. So this is only the possible isomer when longest carbon chain equal to 5. So if you get besides this is actually the same one lah. So actually ni pun again alkene ni pun sebenarnya kena buat nama lah sebenarnya. Here is actually our butene. Here is actually 2 butene. Sebab ni carbon number 2. Okay, tapi naming later we're gonna learn during our chapter 5. Okay, next the longest carbon chain when carbon is equal to 4. So here all of this is actually the same one. 1, 2, 3, 4. Contohnya ni carbon number 2 ni I have my substituent, my CH3 here. So this is actually the same one. But the difference is actually again all of this is the positional isomer where the position of the double bond different. Here between carbon 1 and 2, here between carbon 2 and 3, here between carbon 3 and 4. Okay, so this is all the possibility for alkene. So there's 5. Okay, but then the overall isomer for this one is actually 10, right? So another 5 is actually from your cycloalkene. Okay, so how do you get your cycloalkene though? Okay, it's actually from here. For the cycloalkane, we're going to take the longest carbon chain equal to 5. So if it is a 5, it will become cyclopentane. The shape yang 5 lah. So here is the shape. Okay. Next is the longest carbon chain equal to 4. So when it is 4, it will become a square. But remember this is C5H10. So we need another one more carbon. So I'm going to write down here. So CH3 here. Okay, so memang tak ada any possibility lah. Any other possibility if the carbon is equal to 4. Next is when the carbon equal to 3. Okay, so when carbon is equal to 3, we're going to do a triangle here. But then we only got 1, 2, 3 carbon. So this is carbon number 4, carbon number 5. So we have total 5. Okay, so what is the difference between this and this? So for this one is actually the chain is this is where the CH3 is on the carbon number 1 and 2. For this case, on carbon number 1, we have both of our CH3. Jadi this is our dimethyl. But then how about this one pula? Okay, this one is 3. Okay, but then where previously, this one I'm going to write down CH3, CH3. Yang ini is actually, this is my CH2, CH3. Okay, so this is all the possibility for the isomer. Okay, so that's the solution for the examples on page 10.